Hi everyone, and welcome to today's Micro Minute. My name is Rebecca Duffy, and I'm an application scientist coming to you live from the ZMCC in the Bay Area in California. Today we're going to talk a little bit about the LSM 980 confocal and some really cool things that we can do on that, both with connecting from images from other instruments as well as actually doing something that we call online fingerprinting. And so that is a spectral imaging technique where we can unmix fluorophores on the fly. Just a reminder that we do have, the live chat enabled, so while we're hoping that you'll learn a little something today about your confocal and what you can do with it, we also want you to take advantage of the fact that we come on every week and have our experts here from the Customer Center Live so that you can also ask your microscopy questions, whether it's related to the workflow I'm going to show you today or not. But without much ado, let's go ahead and hop on the instrument. Today I'm going to be walking you through a workflow where we're going to connect an image taken on a wide field system, and we're going to actually align our stage relative to this image that was taken from the Axioscan, and after that we're going to come in and take a higher resolution image and do what we call online fingerprinting, which is actually unmixing several channels at a time on the fly while we're looking at the image live. What we're looking at here is a breast cancer sample. This sample has been stained with the 𝗶𝗀 dye set that you see here. So, a common challenge with these type of dye sets is that on certain systems you might have some crosstalk, right? We have several emission peaks that are very close together. You might have some overlap and bleed through, and then of course we're having a dye that's getting into the NIR range. But today I'm going to show you how we can actually take care of that by saving some reference spectra and using our 34 channel detector plus our 2 NIR detectors to unmix those channels on the fly. Just to give you a little bit of a flavor of what that beam path looks like before we jump into live imaging, what we're going to do is we're going to send our light to this 32 detector quasar here, plus we have an additional 2 PMTs here, making this a 34 channel detector system. This is how we're going to be able to separate and bin these individual channels into 8.8 nanometer spectrally separated bins. We also have this additional NIR detector in our light path that's very sensitive in the near infrared range, so we're going to send some of our far red dyes up here. And this gives us a 36 channel detector system where we can take fingerprints of the known dyes in their sample and then unmix them on the fly. So let's get started. First thing we're going to do, I've already loaded in this image that we took on the Axioscan that is our full slide image, and what we've done is we've created something that we call a ZenConnect project. These are wonderful because you can actually have context now to what you're imaging over time. So this was imaged previously, right? I actually came in and I'd already taken a confocal image, but now I want to actually reopen this project and maybe I want to image some more areas. And it's really helpful to know what you imaged before, not have to rely on your memory or some scribbles of notes trying to annotate. It's all saved in here in the Zen software for you. So all we have to do now is go over into AI Sample Finder. And it's going to find our sample for us. So what it's doing right now is it's illuminating our sample, and it's going to figure out that we've loaded a slide in here. Depending on how well your tissues contrast with the glass, it'll take a dark field image. Sometimes it will identify those tissue sections here if they contrast well with your slide. And if you need to go in and manually draw it, that's fine too. It's called AI Sample Finder because it constantly learns from everything we put on the system. So whether we're putting on a slide or a 96 well plate, you don't have to tell it what you put on there. You just run the wizard and it will tell you what is on there, and if you have a really nicely contrasting tissue sample, it'll actually even outline that for you. But this is going to help us align our sample and where the stage is now to those images taken on a completely separate instrument so that we can actually have our coordinate systems effectively match. So all I'm going to do is outline these thin little sections so that we can make an overview image in the next part of the wizard. And this will help us align with that beautiful tiled overview multicolor image that you saw earlier. So it's actually going to autofocus for us within these regions that we've made. It's really nice. I actually never look through the eyepieces anymore using AI Sample Finder. You don't really need to. And once it's found its focus point, we can pick really any channel that we want to take an overview image with our wide field camera. We actually do have a wide field camera equipped on this system, so I'm just going to go in and I'm just going to look at 𝗶. It's an easy way to make a little map. Okay, and now I can just hit preview scan, and it's going to scan these for us in wide field mode. But again, I selected 𝗶. You could do a regular bright field contrast method. You could select any other dye that you've got a filter set in for. It's really whatever matches your workflow. And you can just hit finish, and we're going to launch into our online fingerprinting workflow. So the next thing I want to do is I have just an initial image. I don't have as many filter sets on my 980 as I had on our Axio scan, which was fitted with one of the 𝗶7 dye filter sets for wide field. I just have one filter set, or two filter sets on here. So I have my reference image that has all that information. What I want to do now is actually align this to my project image. So I'm just going to save my overview image. Just call this 𝗶 overview. Okay. And now what I actually want to do is go into my project. I'm going to add this to my project so I can align the stage. So I'm going to hit Add Image, 𝗶 Overview. It's just that easy. Boom, boom. Okay. And actually, this is very close to aligned with the previous project. Probably because I had to align the stage earlier. But what you want to do to check, you can adjust your opacity here. What you want to do is you can check our opacity and see how well we're aligned. Right, so we're a little bit shifted. Sometimes you might be over here in left field if you've just imported the image from the other instrument, and that's no problem at all, because we're just going to drag the whole image, you'll see. So I'll make this a little transparent so I can see both, and then we just hit Align. And now you can see I have this little alignment module down here. If you had to flip, you could do that, but really all we have to do is move this a little bit down. And sometimes you don't even really need the fluorescence overview image. Sometimes you'll actually have some of these landmarks, like these bubbles, and you can just realign with something like that with your AI sample finder overview, depending on your setup. Okay, looking at this little hole right here as a reference. Sometimes you just have to actually rotate a little bit too, right? So that's really convenient. Boom. Okay, once we're happy with that, we can hit Apply, and now I can actually, I don't really actually care about that 𝗶 overview image, to be honest, right? I really want to look at this, so I can just completely make that invisible to myself, and maybe I want to go back in, I already imaged over here, so maybe I actually want to come in and look more closely at what's going on with some of these blood vessels. I can just double click, and it moves my stage to where these crosshairs are now, right? So we're going to start off with a 20x, and now what you're going to see is we're actually going to unmix these colors on the fly here, right? So just for a reminder, this is our dye setup. We've got several very closely overlapping colors here, and just the markers so that you know what they are. Okay. All right. And so what we're doing when we're imaging this is, like I said, we're unmixing on the fly. We're actually using that 32 channel separated stack, and we're on the fly splitting it into these channels because I saved these spectral fingerprints. So I can go into gallery mode, and you can see we're imaging all of these at the same time. And if I go in and hit snap, we'll actually take a snap of this spot. And since I have started the Zen Connect project, we'll actually see this in our project. So here's our image. We just unmixed 7 channels on the fly. And now if I go into my project, I can see it overlaid right on top of this part of the image. And so you can keep doing that, and every single one of these, when you add them, they'll be saved in here. So, and actually another nice thing is if you open this up later, maybe you've saved a bunch of stuff, you can go in and double click, find out this is new 6, we can open it in here and it'll actually open it for you. So you don't have to go and hunt through all your folders and try to find which one looked like what. You have context everything, and you can double click open it right from the project itself, which is really nice. Okay, but what I want to talk a little bit more about is how did we get here? Okay, so we're unmixing all of these colors on the fly. So how did we actually get to this point? It's really, really powerful when you're doing live imaging where you might have something like a plant sample that actually has some autofluorescence and you need to unmix on the fly. But it's also really nice when you do have these very complex 7, 8, 10, however many colored samples that do have markers that are very close to each other. For instance, in the Axioscan data, this yellow, this 𝗶𝗶𝗃 and this 𝗶𝗶𝗃 are actually quite close to each other. One is a cytosolic marker and one is Ki67. But it can be a little bit confusing when they're all kind of registering the same channel. So it's really helpful to actually see live when you're moving through your sample where your markers of interest are. So what we did to set that up, just so you learn a little bit more about how this works, we actually have something we call lambda mode. And so what that does is we're going to send everything to this 32 channel detector, and these two PMTs as well, and even these NIR detectors, and we're going to collect these in 8.8 nanometer bins. And so we're going to split that image into these individual spectral bins, and from there we'll be able to take spectral fingerprints. So this is what this looks like. I have the same laser set up, but it's called lambda mode. And so if we go into lambda mode, and I show you the gallery, it'll make a little bit more sense. Okay. Let's focus. There we go. So we can see we're collecting all these individual channels. If you look down here, this tells you where each channel bin starts. And so if I were to go ahead and snap this, this is where we can save our spectral fingerprints that I actually use as the reference spectra. In an ideal scenario, you will take your single color controls and do this. What you really want to do if you're doing that is you want to make sure that you'll take your lambda stack, and then things that you really want to make sure that you keep the same are laser lines and MBS, channels, any emission filters that are in place, your detection ranges, objective lens. All of these should not be changed when you're acquiring spectrum for an experiment. In an ideal case scenario, you do have single color controls, but if your samples are spatially separated enough, you might be able to get away with not doing that. And I believe that is what we did with this sample, actually. So what you'll do, you've done your lambda mode setup, and we can go to the unmixing tab. This comes standard on all confocals and even actually wide field. So you have the capability to do linear unmixing no matter what. But what we would do is we could come in and, you know, maybe you need to look at your gallery to figure out, okay, this is definitely, you know, 𝗶𝗶𝗃. So you could go in, and we're just going to do some examples here. You can also do single channel and look at these, right, one by one to try to find your spots and find where you have bleed through. But just to show you how this works, without being picky, we can go in and we can add a crosshair or even draw a little rectangle. And let's say I mark this, and I'll call this, you know, 570 example, and we can add, you know, maybe this is, we're definitely this is only red, and you can see now what your fingerprints are trying to look like. I mean, we think this is like our 690, and you would do this for each one of your dyes. Again, I always recommend, if you can do single color controls, please do that, but if you can't, this is exactly how you would do it. And then from there, once you've added all of them, you're happy with them, you think that you've picked ones that are really only showing that one fingerprint, then you can save it to your spectral database. And as you can see, right, I talked about how important it is to make sure your filter sets match or your objectives match. That's why we have this 𝗶ₚ set with several different setups. But you can make yourself your own folder, and then you would save it here. So again, and you can actually kind of see why the hardware is so important in the spectral fingerprint, because our MBS will block those laser lines. So if you try to do this experiment later and you don't have that same MBS in place, your linear unmixing results will not be as accurate. But so this is the initial setup, and then once you're ready to actually do online fingerprinting, all we did was we imported those into an online fingerprinting track, right? And that's how we can go live and unmix, because when we set up our online fingerprinting, we're taking all those spectral fingerprints that we saved, and now you can see those actually shown here for each of your reference dyes, and then we can just, again, go live and start unmixing on the fly. And that's how easy it is to move from instrument to instrument, align your stage, and start accumulating data in your Zen Connect project for something that seems complex, like spectral fingerprinting, but is actually really quite easy to do on the LSM 980. All right, I hope that was super informative for anybody who wanted to learn more about the spectral capabilities on our LSM 980, how to use Zen Connect to connect screenings from other instruments over to our confocal, which is actually something you can really do on any platform that we have that's running Zen Blue. And if anybody has any questions, I would love for you to put them in the chat. In the meantime, while I wait to see if anybody that was watching live does have questions either related to spectral imaging or just related to confocals in general, I'm happy to answer them. But just a reminder that we do have paid trainings, which are our Skill Builder Workshop series. They're both virtual and in person, so if you want to join us virtually, sit by your instrument, you can click with us as we go. We actually have one for anybody that wants to learn more about how to better use your area scan detector coming up next week that you can still sign up for. But we have those for all imaging modalities, light microscopy, electron microscopy, and X-ray microscopy. We offer those throughout the year, virtual and also in person. If you want to remove yourself from your lab, make yourself come attend a course for a few days, I guarantee you'll get a lot out of it. You can sign up for those here. We, of course, also have free resources for you guys that want to do it yourself, teach yourself how to walk through some of the modules and just need a little bit of help from video training. You can access all of that on the portal, which is the middle QR code here. And of course, you just need to have an instrument so that you can access that, be a current customer. And then, of course, we also have our upcoming live streams. We have, I think, a little break next week, but then we have the Lattice Light Sheet 7, some workflows shown on how to image your living cells as gently as possible. Coming up in a couple weeks, it's one of my favorite instruments that we have in the lab here. And then some X-ray microscopy the week after. So sign up for those, and if we don't have any questions, I'll wait another minute. But as always, your microscopy experts are here just about every week doing a micro minute showing you the newest workflows that we have in-house, and also, again, here to answer your questions that you guys might have as our customers. And if that is all with no questions, I will go ahead and close out today and hope to see you guys either virtually or at the Customer Center soon. Thanks.